Good morning, students. Today we are going to discuss a important topic from the chapter 5, and the chapter 5 is your laws of motion. Now the topic which we are going to discuss is your banking of road. Now I think most of you have seen during the turning the upper edge is slightly elevated compared to the base of the road, and that one is nothing but is your banking. And this happens during the turning of the road. Okay, now what we have written, let me read out. The phenomenon of raising the outer edge of a curved road above the inner edge is called banking of road. Let me repeat once again. The phenomenon of raising the outer edge of a curved road above the inner edge is called banking of road. And this one becomes clear from this diagram. You see, this is your curved road or the turning of the road. Now the upper edge makes an angle theta with the base. What we have written, the phenomenon of raising the outer edge of a curved road above the inner edge is called banking of road. You can consider that one is your outer edge makes an angle theta with the horizontal part of the road. Now let me consider a vehicle is there on the turning of the road. Now the weight acts vertically downward, and the normal reaction is normal to the surface of the vehicle. Now it makes an angle theta with the arrow which is opposite to the direction of the weight. Now under this condition you will get few component as per it is clear from the diagram 2. Now here what we have written, so if r makes an angle theta with the arrow which is opposite to the direction of the weight, then there is a component r cos theta and r sin theta. And again there is a friction, and the friction force always acts towards the center of the curved road, because the curved road is nothing but a part of a circle. So what machines of the engine or the engine of the vehicle do, basically it tries to pull the vehicle out of the center with the centrifugal force which you have defined here, capital F. So frictional force has this component, one is your F cos theta and another one is your F sin theta, and capital F is your centrifugal force. It comes from the engine itself of the vehicle. So you see some forces act towards the center and some forces act upward, some forces act downward. So considering these forces, we have to make some mathematical equation. So let me write number 1 equation, that is your r cos theta, and in downward it is your mg plus f sin theta, or r cos theta minus f sin theta equal to mg. This is your number 1 equation. Number 2 equation, some forces act towards the center of the curved road, that is your r sin theta and f cos theta, and F is, capital F is the force exerted by the engine of the vehicle, and it tries to take the vehicle away from the center. So it has centrifugal, it is nothing but is your centrifugal force, and already we have defined centripetal force. So centripetal force and centrifugal force have the same magnitude or the same expression, but the direction is opposite. Centripetal force acts towards the center and centrifugal force acts away from the center. So it is your F cos theta plus r sin theta equal to mv square by r. So mv square by r is your centrifugal force, which is defined as your capital F. Now v is the speed of the vehicle and r is the radius of the curved road. If you consider the curved portion as a part of a huge circle, then small r you can consider the radius of the circle. Now next part is your simple mathematics. We are going to divide r cos theta minus f sin theta by f cos theta plus r sin theta, that is your mg by mv square by r. So some part get cancel out, mm goes off, so rg by v square. So we are simplifying v square by rg equal to f cos theta plus r sin theta by r cos theta minus f sin theta. Now this part also from the law of refraction, or law of friction basically, also from the law of friction, F equal to mu r. F is your frictional force and r is the reaction. Already we have defined the law of friction. Mu is the coefficient of friction. So if you substitute in place of F by the mu r, then you will get mu r cos theta plus r sin theta, r cos theta minus mu r sin theta. So r goes off, so v square by rg equal to sin theta plus mu cos theta and cos theta minus mu sin theta. So v square equal to rg within bracket sin theta plus mu cos theta by cos theta minus mu sin theta. So v equal to rg sin theta plus mu cos theta by cos theta minus mu sin theta within bracket to the power half. So this is your final expression. You can further simplify by taking cos common. So under that case you will get v equal to rg tan theta plus mu 1 minus mu tan theta you will get. Now if mu goes to 0, we have considered a case where the coefficient of friction is 0. It means there is no frictional force. Under that condition you will get v equal to rg sin theta by cos theta to the power half, that is your rg tan theta to the power half. So these expressions are very important for the numericals. You have to write directly this expression and you have to substitute the value to define the speed of the vehicle. It means during the construction of the road, speed of the vehicle is already defined because r is nothing but the radius of the curved surface. So I think you have seen that during your journey, you used to see somewhere maximum speed limit is 20 km per hour or 30 km per hour or 50 km per hour, like that it is written, no? So based on that construction of the road, the speed is calculated because r is the radius of the curved surface and theta is the angle of inclination. So if your vehicle is or if your vehicle has a speed higher than that limited value which is specified in the road, then there is a possibility of accident. Now already we have said that in the diagram capital F we have specified as your centrifugal force, and the expression already have defined in our previous chapter discussion, that is your mv square by r. Now next topic which we are going to define is your bending of a cyclist. Now you see this is your bicycle rider makes an angle theta with the vertical, and rx normal to the surface of the person who is riding or normal to the bicycle itself. So if theta is the angle makes with the vertical, then it has component. One is your r cos theta, another one is your r sin theta, and both sides vertically downward. So from here you can get the equation. One is your r cos theta equal to mg, another one is your r sin theta equal to, again, that is your mv square by r. Here it is your centripetal force. V is the speed and r is the radius of the curved road, because during the turning or during your journey on the curved road you used to bend, no? Making an angle theta with the vertical. I think all of you have seen the that is your, there is a sports, no? Cycle riding sports is there. So I think you have seen that people are riding cycle, and during the turning they used to simply touch on the floor of the road, making certain angle with the vertical. So that part we are trying to show here. So r cos theta mg r sin theta equal to mv square by r. So if you divide, you will get tan theta equal to v square by rg. So v equal to rg tan theta to the power half. Okay. So this expression is same as this expression. So these formulas are very important. Please go through this part, and this is also important for your exam. And we'll try few numericals in our next class related the formula which we have defined in this chapter. So if you have any query, please put your query so that I can give the answer. So thank you.